So I'm going to go ahead and work through these review problems, and if you are having trouble or can't seem to get the correct answer, hopefully these will help. Once again, I'm not really teaching this material as much as just working out some problems, and you can see how I worked out these problems. So this number one, express the angle as a decimal to the nearest 10,000th of a degree. 10,000ths of a degree, just so you know, tenths, hundredths, thousandths, 10,000ths. So it's going to be 4 places. The whole point of these problems is we have a 100-degree angle, and now we have part of it written in minutes and degrees. I know as a decimal, it's going to be 100 point something, and this is what I need to convert to a decimal in degrees. So basically, the point of this problem is to convert 10 minutes and 40 seconds into degrees. So I'm going to start with the 40 seconds. Now I'm going to convert 40 seconds into minutes by using my unit conversion. We know there are 60 seconds in 1 minute. So this ends up being 4/6, which is 2/3, which is 0.66667. I'll keep 5 digits. And this is in minutes. So 40 seconds is the same as 0.666 minutes. Now I'm going to take this minutes and add it to the 10 minutes here. So now I have 10.66667 minutes, and I want to convert that into degrees. Minutes in the bottom, degrees in the top. Once again, there are 60 minutes in 1 degree. So now I grab my calculator, and I'm going to take 10.66667 and divide it by 60. That's not correct. I must have typed in something wrong. 10.66667 divided by 60. That's better. So 0.1777 looks like just a bunch of sevens. So since I'm going to round it to the nearest tenth, the 7 here becomes an 8. So 1778 degrees. Now the next one sort of flips the script. So now we have an angle written as a decimal in degrees, and we want to convert it to degrees, minutes, seconds. Well, I know from the start it's going to be 27 degrees. So in this case now, I'm taking this decimal part and I'm wanting to convert it to, I'll just write degrees. Whoops. I want to convert it to minutes and seconds. So what I'll do, I'm going to take that decimal part, 0.456 degrees, and I'm going to convert that into minutes. 60 minutes in 1 degree. So grab my calculator. 0.456 times 60, 27.36. Now what I do is I go ahead and now take the whole number apart, this 27, and that becomes 27 minutes. And now I take this decimal part and I want to convert it to seconds. So I take 0.36 minutes to seconds, 60 seconds in 1 minute. So now I have 0.36 times 60. $21.6. Now, since I want this final answer to just to be in minutes, if I round this up, this is going to be, seconds, this is going to be 22 seconds. So there's the answer. The next two problems are converting between degrees and radians. Have an angle 126 degrees, and they want to know how many radians. Once again, I didn't say it, but at the very top of these instructions, everything's an exact answer instead otherwise noted. So these are going to be exact answers. So it's pretty straightforward. Start with 126 degrees. Going to use my unit fraction to convert. Start with degrees in the bottom. I'm trying to get to radians. There are pi radians in 180 degrees. So really what I have here is 126 over 180 times pi. The pi is going to be in my answer since I want an exact answer. I'm not going to put in 3.14 for pi. But I do need to reduce this fraction. So I'm just going to reduce it. Since these are both even numbers, this is like half of 126 is 63, half of 180 is 90. Now I realize that 63 and 90 have a common factor of 9. So I can divide the top and the bottom by 9. And I get 7 tenths pi. Or I could write it a little better maybe. 7 pi over 10 to be clear that the pi is up in the numerator. And now we go the other way. We're given an angle in radians and want to convert it to degrees. Same idea, I'm going to use a unit fraction. Radians here, radians in the bottom, degrees in the top. 180 degrees in pi radians. Now think about this. If you remember canceling, if you have identical factors in the top and the bottom of fractions, since we're multiplying these, this pi and this pi are going to cancel. So I've already got a 7 times 180 over 15. Now I realize I need to reduce this, so I realize that 5 goes into 180 and 5 goes into 15. So I'm going to divide top and bottom by 5. So 180 divided by 5, well 30 gives you 150 and you've got 30 more, so it should be and then I realized 36 divided by 3 is 12. So this really becomes a problem of just reducing fraction. And 7 times 12 Should be 84 degrees. All right, next problem. For a circle with a radius of 8, find the arc length around 2 decimal places for an angle. So obviously it's not going to be an exact answer because it tells us to round it. So this is an arc length problem. So just to refresh our memory, if you look on your formula sheet, arc length, S, equals the radius times the angle. It's very important. This formula only works if your angle's in radians. So they tell us circle with radius of 8. So we know R is 8 meters. And for this problem A, it tells the angle is pi over 5, and that is in radians. So therefore, if we want to find the arc length S, we can just go ahead and plug in my R and plug in my angle in radians. Now, since they want it to round it to decimal places, now I'm going to go ahead and use my calculator. Nice thing is on my calculator, I have a pi key here. Hopefully you do too. So 8 times pi divided by 5. 8 times pi divided by 5 equals. So 2 decimal places, I have 5.026. So that 2, because of the 6, gets bumped up. So it becomes 5.03. I could, just to be clear here, say, so therefore that's the arc length. Now, same problem except they give us the angle in 40 degrees. Once again, I can't just plug in 40 for my angle because the angle has to be in radians. So what do? Well, first thing I do is I need to convert this 40-degree angle into radians. (40 divided by 180 is 4 over 18, which is 2/9. So it's 2 pi over 9 is the angle in radians. So now I can use my arc length equation. So the radius is still 8 meters. The angle is 2 pi over 9. So now I'm going to use my calculator. So 8 times 2 times pi divided by 9. 8 times 2 times pi divided by 9. So 5.585. This 8. Since the number next to it's a 5, that bumps it up to 5.59. All right. Number 6 now. Approximate to the nearest square foot the area of a sector of a circle with an angle of 0.14 and a radius of 24. So this picture may not be perfect, but the idea of the sector is, so if like we have a radius of 24 and the angle of 0.14, and this in here is the area. It's like the area of a piece of pie, according to this picture. This picture may not be accurate, but it's the idea. So once again, on your formula sheet, we do have an equation to calculate the area of a sector. But once again, to use this formula, the angle has to be in radians. Now the nice thing is, that said the angle is 0.14. Since there's no degree sign there, then we know this is a radian. So basically we can plug everything in. R squared, radius of 24 feet. I have to square that times the angle of 0.14. And now this we're going to round to the nearest tenth. So 1 decimal place. So now I'm going to take 24 and I'm going to square it times 0.14, then divided by 2, 40.32, which is 40.3 square feet. All right, not too bad. All right, let's do these next problems, then we will stop this video and start a new one. Reference angles. Remember, reference angles are, you look at your original angle, and the reference angle is the shortest angle back to the x-axis, either the positive or negative x-axis. So for instance, easiest thing is always to sketch these things out. We start here, negative 100s. Remember, negative angles, you go clockwise. So like this would be negative 90. So negative 100 is right about in here. Of course, all the way to the other side is negative 180. So if I'm here at negative 100, and I need to get to negative 80, what is that distance? And reference angles are always a positive number. You don't have negative reference angles. Well, from negative 100 to negative 180 is 80 degrees. So 110, so if there's 90 degrees, 110 is maybe right here. So once again, here is 180. This is going to be my reference angle. What's the angle between 110 and 180 degrees? 70 degrees. 83 degrees. Well, I know 90's here. So 83 is probably right here. This is going to be my reference angle. Once again, reference angle is the smallest angle back to the x-axis. 83 degrees. All right, these last three are in radians, so we're dealing with fractions, so the math can be a little messier. Where is 7 pi over 4? That's actually a special angle. 7 pi over 4, if you look on your unit circle, I've got a unit circle here. There's 7 pi over 4 in the middle of the fourth quadrant. So this is 7 pi over 4. This is going to be my reference angle. And the question is, what is that angle? Well, all the way around is 2 pi. So this is 0, and if you go all the way around, you get 2 pi. Although, if I rewrite 2 pi to have a denominator of 4, 2 pi is the same thing as 8 pi over 4. So if I think about this as 8 pi over 4, I've gone 7 pi over 4. How much more? What angle do I need to have here to get to 8 pi over 4? Well, obviously, pi over 4. Well, it's obvious to me. Hopefully it's obvious to you. All right, negative 3 pi over 4. Negative angle now. It's actually a special angle if it was positive. So what I typically do is I say to myself, well, 3 pi over 4 is right here. So if I want negative 3 pi over 4, I have to go the same distance except the opposite direction. So you go through the first quadrant and halfway through the next one. So therefore, that's going to be negative 3 pi over 4. Now the shortest angle back to the x-axis is right here. So if this is 0, all the way across is pi. Now if I rewrite pi to have a denominator 4, pi is the same thing. Actually, I should have put a negative here since I have negative angles. So here's negative pi. That's the same thing as negative 4 pi over 4. So what would this distance be to get from negative 3 pi over 4 to negative 4 pi over 4? Well, it's going to be negative pi over 4, but of course, reference angles, we always give them as a positive angle. And now the last one, 11 pi over 4. This one's a little tricky because this is not actually in the unit circle, because the unit circle goes from 0 to 2 pi with the denominator of 4. 2 pi is 8 pi over 4. And we're 11 pi over 4. So we start here. Once we get to here, we've got 8 pi over 4, and we need to go 3 pi over 4 more. Well, three pi over 4 more. So this is right here. This angle is 11 pi over 4. Or, if it's easiest to think about it, it's also 3 pi over 4. Because now the idea is this is my reference angle. It's probably simplest to think of being here at 3 pi over 4. Just like the last time, I'm going to rename pi to 4 pi over 4. So I'm sitting here at 3 pi over 4. How far do I have to go to get to 4 pi over 4? I have to go pi over 4. All right, those are the first 7 problems on this review. I'll just go ahead and stop it now and then pick up again in the next video.